No matter where we are, beside a forest lake, at a children's birthday party, or in an airport terminal, sound impressions can influence our well-being and how we perceive the world. Normally, we distinguish between sound and noise. In short, we normally refer to arranged pleasant impressions as sound, while the more chaotic and obtrusive sounds are referred to as noise. There's a fine line between sound and noise. Scientifically speaking, sound is defined as elastic molecular fluctuations in the air or other media that create a chain reaction by putting the nearest particles in motion. The sound will then spread at a certain propagation velocity, which is called the speed of sound in the medium in question. Sound vibrations can be described as a progressive sound wave, which propagates in all directions like rings in water. The number of sound waves per second determine the frequency of a sound. Frequency is measured in hertz, and 1 hertz equals 1 vibration per second. Low-frequency bass sounds have long, soft sound waves with few vibrations per second, whilst a treble sound has many vibrations per second. For instance, the wavelength in air for a sound wave with a frequency of 20 Hz is 17 meters. While the wavelength for a high-frequency treble sound wave with a frequency of 20 kHz is only 1.7 centimeters. Sound waves are thus inversely proportional to the frequency. Sound pressure is normally described using a decibel scale. The higher the sound pressure, the higher the decibels. For decibel measurements to be comparable, they must be made at the same distance from the sound source. The reverberation time is the time measured in seconds that passes from when a sound source is interrupted until the sound dies out. It's the character and acoustic properties of the surrounding surfaces that determine how sound waves behave and spread. When a sound wave hits an obstruction, it's reverberated. If the surface is hard and flat, the sound wave will be reverberated directly, while a soft and uneven surface will absorb part of the sound waves and delay or muffle the reverberation. Normally, a long reverberation time is undesirable, as the echo effect of the first sound waves mixes with the subsequent sound waves. The result is a noisy and resonant acoustic image, in which it's difficult to distinguish individual sounds. With a short reverberation time, the acoustic image becomes more precise and sharp, and speech intelligibility increases significantly. Long reverberation times can be reduced by using materials which are good at absorbing sound. This property can be described by means of a sound absorption value. Hard and rigid materials with a smooth surface often have a low sound absorption value, while materials with a soft, uneven or porous surface typically have a high sound absorption value. The higher the proportion of the room's total surface area that absorbs the sound, the less reverberation there will be in the room. It's therefore important to select a material with a high sound absorption value for large surfaces. In this way, it's possible to regulate and reduce the reverberation time to achieve a good acoustic environment with a clear acoustic image. The ceiling will usually be the easiest surface to regulate acoustically, since it's both large and accessible. At troldtekt, we've specialized in combining good acoustics and beautiful architecture. All new products in the troldtekt product range are developed in close collaboration with architects. This ensures that troldtekt is always the answer to acoustic challenges, whatever the type of building. The troldtekt product range also includes a number of special products which enable, for example, integrated ventilation, decoration, lighting and concealed speakers. So please don't hesitate to contact us if you're involved in building projects that require better acoustics. Troldtekt, we have an ear for good acoustics.